Welcome to Dynamic ARP Inspection, the 8th video in the Tellabs Optical LAN System Architecture and Application series. In this video, we'll explore the basics of Dynamic ARP Inspection and its application to Tellabs Optical LAN systems. The topics covered in this video will be an overview of Dynamic ARP Inspection, the options available for configuration of DAI in the Optical LAN system, and some applications for its use. Dynamic ARP Inspection provides protection from ARP spoofing attacks and helps to ensure that the proper MAC IP binding is maintained in the ARP tables of the switch. ARP spoofing occurs when a host uses a gratuitous ARP to bind its own MAC to an IP address that it wants to spoof. If accepted, the gratuitous ARP will cause all devices on the subnet to update their ARP tables to send traffic to the hacker's MAC for traffic to the spoofed IP. Typically, these are man-in-the-middle attacks, and the hacker will intercept and then forward the traffic to the correct MAC for that IP binding, so that the victim is not tipped off that their traffic is being diverted. This attack only works within Layer 2 domains. Once the hacker has redirected traffic, he can then inspect, modify, or drop the user's traffic on the subnet. Dynamic ARP Inspection works via two mechanisms. The first is DHCP snooping. DHCP snooping allows the system to maintain a database of DHCP entries with MAC to IP address bindings. This table is used to track the legitimate binding of MACs to IPs and ensure that all ARP entries agree with the binding from DHCP. Dynamic ARP Inspection also uses ACLs to handle static IP addresses and maintain those entries in the database. In Tellabs Optical LAN, DAI must be enabled globally in the OLT for the DAI features to be permitted for use on the OLT. When the admin state is enabled, DAI support will be turned on. Logging admin state defines whether to log the events occurring during DAI processing. Setting logging type to deny will log only denies on dropped ARPs. Permit will log only permitted ARPs. And both will log both permitted and denied ARPs. Typically, you should only log denied ARPs unless debugging a situation. Logging all permitted ARPs can cause logging of hundreds of events per second. Enable Destination MAC Check ensures that the destination MAC of the Ethernet header agrees with the target MAC in the ARP body of ARP responses. This should typically be enabled. Enable ARP IP Check ensures that the IP address is a valid IP address and will exclude all invalid IP addresses. IP is checked in all ARP requests and responses. This is typically enabled. Enable Source MAC Check verifies that ARP header and body have the same source MAC address in both ARP requests and ARP responses. This is typically enabled. If desired, source IP protection can be added. If this feature is enabled, once the source IP is bound, it will drop all packets that do not match the source IP to MAC binding learned from DHCP. DAI is commonly used in networks where devices obtain IP addresses via DHCP. It leverages DHCP snooping to build a trusted database of IP to MAC address bindings, validating ARP packets to prevent unauthorized devices from spoofing ARP replies. In environments like financial institutions, government networks, or data centers where security is critical, DAI ensures only legitimate devices communicate by filtering out invalid ARP packets that could be used for man-in-the-middle attacks. DAI is deployed in multi-VLAN environments to prevent ARP poisoning across VLANs, ensuring that devices in one VLAN cannot spoof addresses in another. In scenarios where internal devices might be compromised, DAI prevents malicious or misconfigured devices from disrupting network communication through ARP spoofing. In environments like universities, hotels, or public Wi-Fi networks, DAI helps secure the network by ensuring only authorized ARP traffic is allowed, reducing the risk of attacks from untrusted devices. The port profile allows disabling DAI on specific ports for valid network requirements that conflict with DAI rules. Trusted ports skip ARP checks, though this is rarely needed. For example, devices using IP version 6 or non-IP version 4 ether types, or proprietary non-IP protocols may not support IP to MAC bindings, preventing ARP or DHCP snooping. Devices with the DHCP trust status set to untrusted are restricted to transmitting only DHCP client messages. This configuration prevents unauthorized devices such as routers, gateways, or modems with enabled DHCP server functionality from disrupting network operations. Conversely, devices configured with a DHCP trust status set to trusted are permitted to transmit DHCP server messages. By default, the DHCP trust status is set to untrusted. Some devices have static IP addresses and therefore are never going to send DHCP messages. The DAI agent can learn the IP and MAC from a static IP when it ARPs. This is allowed if the IP in use has no learned binding. The binding will be added to the table. Static IP will be learned automatically, but in highly secure environments, this may not be acceptable. This concludes this video. In it, we have discussed an overview of Dynamic ARP Inspection, the options available for configuring DAI in the optical LAN system, and some applications for its use.